Life is what happens while you're busy making other plans. It's always good to start with a quote of someone more intelligent or more outspoken than you. But maybe you can relate to the second line. Development is what happens while someone is busy making regulatory required plans. You've all seen this probably. Teams are getting larger, the tasks are split more among people, and the people that really create the regulatory required plan, for example, the verification and validation plan, they are separated from the developers. And that's not a good thing, because developers, they have a natural approach to testing, what it's all about. And they have their ideas, and these ideas should find their way into the regulatory required plan. So there's already the first takeaway on the first slide, which is don't let regulatory documentation and reality drift apart. Because when the horse has bolted from the stable once, it's really hard to get it back. Yeah. My name, as Carl so kindly said, is Thomas Bohnen. I'm the CEO of Keymkr. We are a service company, and we assist medical device manufacturers in creating compliant products, compliant to standards and regulations. And along the way, we create the technical documentation. This is not only for CE mark, but also for international markets. We've done several 510Ks over the last years, so we also know that. The last point, product testing, we do have an accredited test lab, and this is accredited for safety and performance testing of active medical devices. And you will always hear the active medical device background in everything that I say. But I really hope that you can transfer what I say to your products, be them non-active, maybe sterile, or an IVD or pure software. I think what I have to say applies to all of these kinds of devices. So why do we deal with this topic of verification and validation planning? We have our design input. Several sources, very diverse. This is not even a complete list. There are the risk mitigation measures or software requirements. Many topics are on the list. This is just a selection. And the most simple form of verification and validation planning is you devise a test for each of these type of requirements, and then you're done. No, you're not done. You have to say, all of this needs testing, and it will be tested, promised by Scout words of honor. Yeah, that's it. But that's not it, really. This is what I call the boring plan. It's not only the most boring document that you can imagine, but it's also not of any use at all. It simply states the obvious. And the big question is, how can you do the planning that it's really helpful, to make it worthwhile going into the details and putting in the effort. And to do this, or to answer this question, we'll go a little deeper into 3 types of projects. And the first is the remediation project, which is basically an update, what we've seen over the last 7 years many times, going from MDD to MDR, or going from IDD from IVDD to IVDR. These are the remediation projects, and we'll go into the details what I mean by this in a minute. The phase project is more of the classical approach where you have one phase after the other and develop towards a certain goal with your project. And the third version is the agile projects that very much define themselves along the way. And what all of these projects have in common is they have some cycle within. You know, the cycle of designing something, building, testing, evaluating the test results, and then going into the next design cycle. But this cycle is applied differently over the three project types, and we will have a look into that. The remediation project is the easiest one because the design is skipped normally. The remediation projects, so the simple update project, they often start with the premise that no design changes are done to the product, and it's simply to update documentation. But this very often also includes that tests need to be updated and reperformed. So something has to be built or manufactured, if it's a serial product, so that you have something to test. It's basically one loop. It's not even a complete loop, but it's only one loop with one test phase, and that's it. And this is the only project where the boring verification and validation plan is okay. It's absolutely sufficient, and it's not worth putting any more effort into it. Yeah? You just list what you have to test, you plan what you need to do, and that's it. The remediation project. The next one is a bit more complex. Yeah, you have a more complex content of your development project. Maybe you develop a variant, or it's a product update with some smaller features. But normally today, limited complexity, certainly no technology development, just plain product development. And the limited number of loops, which I somehow named above: concept phase, a design phase, an industrialization phase, and some refinement at the end. You have 4 phases. You have basically 4 test phases of different intensity and different depth and different scope. And you need to test what is your scope, because the test that you do within the design loop is very different from the test that you do within the industrialization loop. Yeah? During design, you try to prove that your product, that the single or the very limited number of hand-built development prototypes, that they perform their intended function. And with the end of the industrialization cycle, you need to prove that the mass-produced article is as good as the ones from the previous phase. So testing has a different scope. It might look entirely different just because of the sheer numbers. Yeah, maybe during the design phase you have 5 prototypes, and during industrialization you need to prove, you need some statistics, and you go into the hundreds. Yeah, so testing is very different, and this ends in the fact that you need to plan the verification, the testing for each phase separately. Yeah? A special role always plays the final test loop, yeah, the final verification and validation test loop, which normally is the only test documentation that goes into the tech file, into the CE file, or into the 510K submission. So this needs to be complete, and these are selected tests of a different scope. So it's one test goal per loop. So you need to plan the tests for each loop separately. Yeah. So, third type of projects, the agile projects. Yeah. The characteristics of the agile projects is that the development loops are very short. You have very quick iterations. You do small incremental changes and then test again. Yeah, and the test scope is completely dependent on what you added to the design. And one of the premises of agile development is that you do not have a fixed plan from the get-go, but you plan your development or you develop your product along the way. And the definition, the very definition of the product also is created along the way. So the test needs to be created along the way. So test planning looks differently. So in the at the start here, at the kickoff for the design, you can basically state that test planning is to be done within each cycle. Yeah, you can state some rules for this test planning, and you can state the documentation that is required, and you need to state where you want to end. But the content of the single tests from these single loops, they only can be created along the way. Yeah? But there are two extra plans that you need to have. If it's a software product and you plan, or at least you consider refactoring once in a while, maybe you have an extra plan for refactoring of software, because this might be a very different development cycle than those where you just add some features. Yeah. And there's another test that has a special role. We already had that. The very last one, which is responsible, or which is the basis for the release of the product or the software. Yeah. That's once again a question of, you need confidence in the completeness of the test that you have in the end. And sometimes it's very hard to add up all the tests that you made along the way and the documentation that was created along the way, to state in the end, okay, this is really complete and sufficient. So maybe there's an extra cycle that recreates some testing from the previous cycles. And yeah, all this needs to be planned, and I'm very sure it's worthwhile. So after the why, we now come to the how. We already saw the list of requirements. Very diverse, or wherever they come from, somehow they have to go into some test specification. Yeah, be it a verification test spec or a validation test spec. These test specs, they might not look that different. So I put them, I treat them as one box here. Yeah, and you can put several requirements into one test spec. Then we have two routes to go. In the end, we want to attribute a special one single verification test spec to a test phase. And we either can do that directly and say, okay, verification test spec number 43 needs to be done next time. Or if there are too many, we might want to group them into blocks. What I mean by blocks, you will see over the next slides. Yeah, these are test specs that you can group together, and the decision, do I want to group them, or how large should this group be? The touchstone for it is, where can I attach what I call the project management price tags, because now we shift a little from the view of regulatory required to project management, which is very important. Yeah, you all know that. And the project management price tags are: what's the duration? How long does it take? Or what's the actual working time? No, sorry. The actual working time is the effort, yeah, in days, in hours, whatever is your currency. And the duration is how long does it take, yeah? For example, if you need some EMC testing, you might know from the number in euros, it might be 8 or 10 days of work, but an EMC test will most certainly not done within 8 or 10 days or within 2 weeks. Yeah, normally you have to plan a duration of, I don't know, 4 to 6 weeks in the EMC lab. Yeah, and this is where project management really kicks in and has its say in verification planning, or needs information from verification planning. And there might also be resources that are needed. Yeah. For example, a budget for an external test for said EMC test, or you need space within a certain workshop or a lab. You need equipment. You need calibrated equipment to make tests that go into the CE file. You need people. You need devices under test. Maybe you need accessories. There's a lot to think about when planning a test, and this, if you reverse it, there's a lot that can go wrong, or a lot of things or people or time or whatever can be missing, so that the test doesn't work out. So it's really worthwhile doing a thorough planning. Yeah? And on this slide, on this level, the question is: decide on which level to attach the project management price tags, because this is the level that you plan on. Yeah. So now we dive more into the practice. How does that look like? And if you use your favorite ALM tool, which is of course Aligned Elements, you have, for example, the technical requirements, and you trace them to a verification test spec. And here you have the verification test spec, which you use for planning. So what are the attributes that we, with our Medulus configuration, use to do the planning? We ask the test procedure: is it new or is it established? So do I have to write the complete test procedure, the test specification, or can I pull it from the database? Yeah. Writing a test specification also requires some time and some effort and some brains, and should be factored in when planning. Yeah. Next question is tools and equipment. Is it available, or do we need new tools and new equipment? And if so, can I buy it from a catalog? Yeah. Is it some measurement device that I can order with Keysight or Perkin-Elmer or whoever? Or is it something that needs to be developed? Yeah. When I have a very innovative device, maybe there is no test device to prove the functionality, and I have to develop the test device myself. Yeah. Think about the time and the resources that go into that. Yeah. Yeah. What's the equipment? A short list. In which lab should this be done? Here it's in our in-house Keymkr test lab. What's the test object? And this can be a phased approach. So we can have 3 tests or 3 test steps. Yeah. This verification test spec might be performed 3 times. Yeah. A good example could be a usability test. Yeah. You can do the first usability test by printing out the screen on paper and showing it to the potential users. You can do it with a simulation on a laptop, or you can do it with a finished device. Yeah. 3 steps, 3 different test objects, but always the same test procedure and always basically the same test goal. Yeah. The last point is was added from our own test lab guys. They said, okay, you have to think about the post condition. What will the device under test look like when we are done with testing? Yeah, maybe it's something that goes directly into the bin or in the know-how box, as they call it. So maybe the device is completely destructed and not usable for anything anymore. Yeah. So these are the attributes to consider when planning the tests. And what does the test planning actually look like? Here's our list of test specifications, and here you can see what I mean by a test block. Yeah, some mechanical lab tests, here the weight test, dimensional tests, and whatever. These are done in the same lab by the same people, basically with the same setup. Yeah, so why not group them and say, okay, we need 2 days, 3 days, whatever for these tests. On the other hand, you have standard tests, for example, IEC 6601, a large test that you would most probably give to an external test lab and where you once receive the report back. This is one test block in itself. Yeah, you need a budget of several thousand euros and you have to plan some weeks to get the completed test report. This is one test block. And yeah, that's how it goes. Yeah, you have your test block and you can attach duration, effort, and cost. And in this case, you have 4 verification test specs, which are basically one test run that you attribute duration, effort, and costs. And what you also can add are some tags for the phase planning. And if you add these tags and you can filter your views in the tool, you can make the step from the test planning to test scheduling. Yeah? And this is what you can see as example here. Yeah, the standard test 6601 is here planned with 4 weeks, and there's another device for EMC testing, for alarms, and so on. And this is normally the point where the project managers start to sit up straight and start asking questions, because this is their view, this is their currency in which they work and think. You know the number of devices that you need, you know if you add 2 more devices or you remove 2 devices, what happens to the schedule? Yeah? Will it expand or will it shorten? Yeah? You can think about the logistics, which device needs to go where. Yeah? This is really practical information that you need before starting such a, in this case, final verification phase. Yeah? And this, if you provide this document to the project manager, or better, you discuss all of this with him or her, then you really have a verification and validation plan that is worth the effort and has really a use and is not only a regulatory exercise. So, in essence, the summary: treat the regulatory required verification and validation plan as something that you actually intend to use. It's worth it, promised. When planning, talk and think through with actual developers, because they know a lot about testing and they already have a semi-ready test plan in their minds when they start with their tasks. Talk to the project manager to see what the milestones are that require a definitive test result. Or, even better, make your V&V plan and tell the project manager where the milestones should be. build up test specifications in parallel to development, because also a test specification needs time to mature. Yeah, it improves over time. Maybe you can reduce effort or time or duration. Yeah, and let me tell you, it's no fun at all to write all the test specification on the last stretch of the project. Yeah, that's not good. Use a tool to provide a single source of truth for testing and results. And by use a tool, I mean, of course, check out aligned elements and have a look into our modulus configuration for it. And don't let anybody tell you that verification and validation planning is simple or boring. Yeah, to my mind, it's the most important document that the project manager can lay its hand on. So that's it. Thank you for listening.
Thank you for an excellent presentation, Thomas. I have tons of questions for you here. Ivo, one of the presenters, he's asking you, how often do you need to invest into revision of requirements before you can write test cases for it? I guess this is a question about the maturity. Like, do you have a heuristic for, can you tell when a requirement is mature enough to write a test case, or is that a case-by-case decision?
It's case by case. The projects are so different. When you think about, you have something technology driven from a startup where at the start, even the developers don't know what the product looks like in the end. This is one pole of the end, one end of the pole, and the other end is you have some remediation project where the product is absolutely finished, and you just need to catch up with documentation and everything in between. Yeah. But normally, when you're approaching the time that you have the first real prototype, the requirements are fixed by reality sometimes, and then you can easily start writing test specifications.
Do you have an opinion on when to start test execution? I have come across different schools here. Some say that we will not allow test execution to start before a test plan is formally released and signed off. And others say what we test is the device towards the requirements. And what the test plan says, that's summarizing what we're going to test. They are not dependent on each other. Do you have an opinion there?
What I completely left out in this picture, because I focused on the regulatory required verification and validation, is this topic of engineering tests. Yeah, where the developers do not have a fixed pass-fail criterion, but they see how far they already have got in regards to performance. Yeah. And this should start as early as possible. I mean, as soon as you build something, and I'm always pro building as early as possible, and maybe even if the product looks very simple in the beginning, start early as possible, and don't wait for the test plan.
That sounds good, and that takes us into the realm of dry runs. Maybe they are similar to what you talk about with engineering testing, but I think that dry runs also have another aspect there. It's basically checking that the test cases are sound, because as you say, the test cases mature. It's not a given that a test case is perfect, and it's a very common reason for failing tests. It's not that the device is incorrect, but that the tests are incorrect. Do you have an opinion there on dry runs? Is that something that you should officially plan for and allocate budget to?
I would hope that a test isn't performed during formal verification for the very first time. But if you have, let's say, 2 or 3 generations of prototype that you already did the testing with, the test matures along with the product. So there should only be a handful of tests in the end where you say, okay, this is just a formal thing that we need for the verification. And there, yeah, maybe you wouldn't need a dry run. So I would advocate early testing and testing often and maturing the tests along the way.
All right, so if you are standing and you got to start the formal verification and you have lots of test cases that you have never run before, informal or during a dry run, then you're taking a risk. That's what you're saying.
Yeah, right. This is another topic that you can talk about when planning verification. It's about project risk management. What do you test first? Yeah, what is the most risky function? Which function, if not working properly, could kill the whole project? Yeah, you should test this as early as possible, and it doesn't matter whether it's a sensor or electronics or usability. Test early. That's the key.
Yeah, you're also owner of an accredited test lab, and that's also a different kind of tests that are done there. Are there any specific things that you need to consider when engaging with an external test lab as opposed to conducting the test cases? Is it like if you send a device to a test lab, you'll never get it back and these kind of things?
You probably won't get it back in one piece. Yeah. It's basically the same advice as with internal testing. I would challenge the test lab that I plan to use during the final verification along the way. So why not take a prototype to the accredited test lab? You do not have to test the complete standard from A to Z. You just select the areas that you think are risky and important, and you just test them. And if you skip the formal report, you can reduce the effort, so it doesn't cost as much as a complete test. Yeah. So it's basically the same advice. Yeah. Define your test in a very limited area and start engaging with the external test lab. And if it's a good test lab, it will go that way. We do it.
I know about a good test lab. Matthias is asking a question here. I suppose making a robust test plan before running into testing itself is best practice, independent of the area of working. Wouldn't you agree?
I think the robustness of a test plan highly depends on, is it the fourth iteration of a device that you develop? So you've already done it 3 times and you know what to do and what to test. Or is it a first? If it's a first, don't expect too much robustness in the plan or in the requirements or in risk management or in anything. Yeah, you know, all these things evolve during development.